We've been learning all about ionic compounds. In this lesson, we're going to learn how to name them. For example, if you see on the back of a bottle of medicine that it has MgOH2 in it, how would you name that? Turns out it's called magnesium hydroxide. And in this lesson, we're going to learn to go from the formula of an ionic compound to the name, or the other direction, from the name of an ionic compound to the formula. First, let's review ionic compounds, and then let's learn how to name them. How do you name something like NaCl? Well, the first thing you're going to do is you're just going to write down the name of the metal. And so you always just write out the full name of the metal, and the name of the metal always comes first. And in this case, Na, sodium, is the metal. And so you can notice over here where we spelled out the name, we've just written sodium. And one thing that's important to remember is whenever we list an ionic compound like NaCl, we always list the metal first. The next thing we're going to do is we're going to take the base name of the nonmetal, which basically just means the first syllable of our nonmetal. And our nonmetal in this case is chlorine, so all we're going to keep is the chlor part. That's the base name. And the last thing we're going to do is we're going to add the ide. And so that's how we get chloride up here. Chlor comes from the base name of chlorine, and ide is just something we tack on to the end of ionic compounds. So NaCl turns out to be sodium chloride. Let's take a look at a few more examples so you can get down this process of going from the chemical formula to the name. So let's say we have something like NaF. What do? Well, we need to go identify what the names are for Na and F, and we just do that based on the periodic table. So we go to the periodic table and we look up what Na is, and that turns out to be sodium. And then we're also going to look up what F is, and that turns out to be fluorine. So F is fluorine. And we're just going to keep the base name of fluorine because that's the nonmetal. So sodium, we've already written out the name of the metal there. And the name of the nonmetal, we're just going to keep the fluor part of it. So I'm going to write fluor here, and I'm going to drop the ene. And the last thing that we do here is we add ide. So that's writing down first the name of the metal, then the base name of the nonmetal, and adding ide. That's what we have to go through each time when we want to go from a chemical formula to name the name of that compound. Let's do a few more examples. Let's say we have Na with a 3 and then an N. Now that 3 means there are 3 sodium atoms in that compound, but that doesn't change how we write the name of it. So we can basically, when we're going this direction from chemical formulas to the names, we don't have to worry about the numbers written there. And what we're going to do is just the same exact thing. We're going to go look up what Na is, which again is sodium. We're going to go look up what N is on the periodic table. And N turns out to be nitrogen. We're going to keep the base name of nitrogen, which is just NiTr. That's the base name of nitrogen. And we're going to add that ide at the end. So it becomes sodium nitride. So sodium nitride is the name of Na3N. Let's do one more example of going from chemical formulas to the name. Let's say we have MgBr. Well, again, we're going to go to the periodic table and we're going to look up what Mg is. Turns out to be magnesium. That's our metal. Remember, we always list the metal first in ionic compounds. And then we're going to go look up what Br is. And Br turns out to be bromine. And so we just keep the base name of our nonmetal, which in this case is brome, and we're going to add ide. So we write down here next to sodium, brome, and then we add our ide. So that becomes magnesium bromide. So going from the chemical formula to the name is relatively straightforward. It's a little more complicated to go the other direction, to go from the name to the chemical formula. So now we're going to be given something like barium nitride, and we're going to be asked, what's the chemical formula there? The reason this is a little harder is when barium nitride is listed, it doesn't tell you how many bariums there are or how many nitrogens there are. And so we have to go through a process to figure that out. We want to know that there's 3 bariums and 2 nitrogens. And so the process we use to figure that out is basically we have to predict the charge of each of our ions, in this case barium and nitrogen, and those charges will actually tell us how many of each element type there are. And the reason this works is that all ionic compounds have to be net neutral. That is, overall, they have just as much positive charge as negative charge. And so we can use the charges on our elements then to balance it out. Let me show you what I mean. So let's say we're given sodium oxide. How do we name that? The first thing we do, step 1 down here, just says, write the chemical symbol for both elements. So the chemical symbol for sodium is Na, which you can get from the periodic table. We've also used it a few times in this video. The symbol for oxygen, which is just what oxide is O. So we have Na and O. Step 2 says predict the charge of each ion. And that's where it's really important to have watched my video on predicting the charge of an ion. If you don't know how to do that, you're not going to know how to do this next step. So it turns out basically the column that an element is will tell you what charge it takes on. So Na is in the first column, and elements in the first column tend to form a positive 1 ion. Oxygen is way over on the other side of the periodic table, and it tends to form a negative 2 charge. And the last step we're going to do here is we're going to cross over the charges, and that's actually going to make sure that we have a balanced compound. So you can see here, since sodium is positive 1 and oxygen is negative 2, then we're going to need 2 of those sodiums to pair up and make our charges neutral. And so we can just figure that process out. A shortcut to figuring that process out is just crossing over those charges. Here's what I mean. Take the sodium charge and cross it over down here to the oxygen. Take the oxygen charge and cross it over down here to the sodium. So now I'm going to rewrite this as Na with a 2 and O with a 1. So that 2 came from the fact that there was a negative 2 on oxygen. And that 1 came from the fact that there was a positive 1 on sodium. So sodium oxide turns out to be Na2O. And now I wrote down the 1 there to be clear, but usually we just leave off the 1. It's understood that if I write down the element O, there's at least one of them. So the 1's just sort of assumed to be there. So Na2O is our final answer. Now you notice in step 3 I say reduce the ratio if necessary. I'll explain what I mean when we get to an example where that's necessary. All right, the next example we're going to take a look at is lithium fluoride. Again, we're going to go ahead and write the chemical symbol for both of those elements. And if we look up lithium on the periodic table, we'll see that it's Li. And if we look up fluoride or fluorine on the periodic table, we'll see that it's F. And now we have to predict their charges. Lithium is also in that first group with hydrogen, and it turns out to form a +1 ion. Fluoride is in the group on the other side of the periodic table, and it tends to form a -1 charge. So now we've predicted their charges. That was step 2. The last step, again, is cross over those charges. So I'm going to take this 1 and I'm going to put it down there. And I'm going to take this 1 and I'm going to put it down there. And that's going to make sure the lithium fluoride's balanced. So we have Li, or neutral I should say, F. And we have a 1 for lithium and a 1 for the fluorine. Now that should make sense because lithium's +1, fluorine's a -1. So if I take +1 and add it to a -1, I get 0, or a neutral charge. And that's what we always want for ionic compounds. So now I'm just going to erase those 1s because we don't usually write them down. It's just assume. So LiF is our final answer. Okay, one more example of going from the name of a compound to the chemical formula. Barium sulfide. So again, we start with step 1, which is looking up the chemical symbol for both of those guys. And we get Ba for barium. And we get an S for our sulfide. That's done with the periodic table. Then we predict the charge. That's done by their position on the periodic table, as discussed in my video predicting the charge on ions. Barium turns out to be +2, and sulfide turns out to be -2. And now we do the last step, step 3, which is we cross over those charges. So this 2 comes down here, this 2 comes down there, and we get barium with a 2 there, and then sulfur with a 2. Now you might have said, well, wait a minute. If barium's +2 and sulfur's -2, shouldn't I just be able to put 1 of each together and have it be neutral? +2 minus a 2 gives me 0, a neutral ion. And that's exactly right. And you can also see that if you take the ratio of the number of anions, sulfide in this case, to the number of cations, barium in this case, that it's 2 to 2. And we can just reduce that to 1 to 1. So whenever you have a ratio that's not in its simplest form, we can always reduce it. And that's the second part of that step 3 there that you need to do sometimes, but not always. And since just 1 barium and 1 sulfur turns out to be balanced, that's the simpler and correct way to write out our chemical formula. So we're going to just get rid of those 2's because we can reduce the ratio to 1 to 1 from 2 to 2. And so that turns out to be the final answer for barium sulfide, BAS. Now, what we haven't done is talked about elements in the D block. So it turns out here we've been predicting the charge of those ions based on their position in the periodic table. Elements in the D block, which are in the middle of the periodic table, you can't predict their charges based on position. So there's slightly different rules for naming compounds in the D block. And that's the subject of my next video on naming. So go ahead and watch my next video on naming ionic compounds, which deals specifically with these elements in the D block. You also get more practice going through these rules.
Hey, hey.